Hello, Parcel Fest. How are we doing? Yeah, great. My name is Will. I'm a research software engineer, and I work in Globus Labs. And today I'm going to be talking about one particular project, Garden, and one particular problem we are working on within that, which is how do we make it intuitive for our users to package up containers to do remote inference on their machine learning models. Real quick, I am part of a much bigger team. Accelerate is a group that's like, to a first approximation, working on grants that Ben Blazek has. I work closely with Owen, Ben Gluski, who you heard from yesterday, Ari and KJ on Garden. And so Garden, this is our we have a nice leek logo, lots of horticultural puns. Our mascot is Sherman the leek. And Garden is a platform for publishing and sharing scientific machine learning models. On the publisher side, we are a place where you're a chemist who's made some novel machine learning model. You can publish that on Garden, and it can be citable and runnable. We take care of the hosting, and you have a nice citable artifact that you can link to in your paper. On the consumer side, we want Garden to be the place where it's like, hey, where do I find the best collection of ionic potential models as a chemist? For all of these little scientific niches, big or small, Garden can be the place where you can find the state of the art and test it out and use it in your own production workflows. So there's like, within the realm of doing hosted inference on scientific ML models, there's like so much we're excited to do and so much we can do. We get these models together, we can do better benchmarks. We can host really big models and like provide gateways and like really ease the burden to using that kind of stuff. And we're really excited for this. We're laying the groundwork for this. Today, I'm going to talk about something more prosaic, which is I want to make Chris's life better. So we really need to like nail the basics on Garden. And here is one particular user persona we are honed in on. Chris Redmond is a software engineer at the Data Science Institute here at the University of Chicago. He works with these postdoc Schmidt Fellows and other people in the Data Science Institute, and they are research scientists. They make models. They have some messy GitHub repo that they got working kind of once on their machine or on a cluster, and they say, Chris, I'm about to publish my paper. I need this model to be live somewhere where people can use it when I publish the paper. And Chris says like, all right, cool, let me do that. This is not like a 100 billion parameter model. This might be a scikit-learn model. This might be a small torch model. But these researchers need a DOI and metadata for citations. They need a place for this model to be hosted. And it needs to not just be cited, but like runnable. So we want remote inference and ideally a path to take from somewhere where people can just mess around with the model to get this on like an HPC endpoint where they can bring their own allocation and use it in a production workflow. And making that happen kind of ties into what you heard from with Ben Gluski yesterday, where we're figuring out how we transfer containers we make in Docker to Apptainer for running on these different HPC endpoints with Globus Compute. So let's dig into both sides of this. There's consumer and producer. We're going to look at consumer first. On the consumer side, you want to find a Garden that's relevant for you. And what does that look like? Oh gosh, I don't want closed captioning. Go to the gardens.ai and you search. You find something that's like, oh, great, I do a lot of steel alloy research, what's out there? Or maybe you got linked here from a paper. We give you convenient example code of like, hey, here's how you use our client library to pull this in. You pull in the Garden referenced by DOI. Methods on it are the methods that the publisher made that runs their machine learning model. And then you run it. Here's an example notebook where I'm running a Garden I published that has a cell penetrating peptide generator from our collaborators at MIT. Look at these peptides, they're beautiful. So that's what it looks like from the consumer side. We have a solid prototype. And clearly we got those models published, so we have a publishing prototype too, but this is what we're currently iterating on the most is the publisher experience. Our first draft had like too many rough edges and we're reworking it right now. And as we're reworking it, we're wondering like, okay, what's like the state of the art today? Scientists who are doing this and getting their papers out, like what's their current workflow and how can we meet them where they are? And a lot of what that current workflow is, here's another set of collaborators at Argonne, Hugh and Park, L.U. Huerta. They released this great paper on materials property predictions. And along with the publication, they released this collab notebook, which it's like, all right, man, get all these packages installed, set up some directories, yada, yada, yada. Then at the very end, here's the punchline, run inference. This is the thing that they actually wanted to expose. You had to go run a bunch of cells first. But collab was like a really convenient way for them to get this out because it solves a lot of problems. Like you can't mess up your virtual env, you're in the notebook, you're just there and you're doing it. And you have a tight feedback loop as you're fiddling with libraries and getting your code to run. And so we are currently working on Garden, getting close to that ease of use. This is actually similar to the workflow that Zhao was talking about yesterday with Diamond, where start with a base container that has a lot of the stuff you need already. I want Python 3.10, I want Torch. Call this, and we spin up a clean container with Jupyter locally and advice on how to structure a notebook that will go set up your environment. And at the very end, have your punchline function actually run my model. And you decorate this. And this is how we know this is the particular function that we are going to register with Globus Compute on the container that we build out of this notebook. If you can, yeah, 1 minute, great. And once you're done, you can publish it. It'll go online. People can run it and play with it. And then ideally, they can also transfer it to HPC endpoints they have allocations on. Fun technical details of how this works, because by the way, we have a normal set of slides for oh, you're a chemist. We're going to solve all your problems with Garden. Life's going to be so great. This is a dev focused talk. And a lot of my audience is the Globus Compute devs. So 6 months from now how I hit a weird edge case. Here's how. Someone makes this notebook. And what we do on our end, we spin up the base container. We run the contents of the notebook, side effects encouraged. We use DIL to save the interpreter state. And the function that we are registering unpacks the state of the interpreter and runs the particular pipeline function. From the user's perspective, it's like we froze their notebook in Amber, but we have one deterministic process of doing this. If you can run all and restart, it works. So yeah, that was a really quick hyper run through. Thank you to our funders. Thank you. Have any questions?
Two questions. First, if I submit something to Garden, do I get this DOI? Do you have so if I submit something, I get this digital object. Okay. And the other question is tough. I'm not sure if I should ask, but I will do. How different is Garden from, for example, services like CodeOcean, where I can also upload objects or artifacts and people can work on it revision-wise. We can also execute the different stuff I can upload. How different it is?
So I'm not deeply familiar with CodeOcean. Is it sort of like a general, you have a REPL and a VM they set up for you?
How it's working, you have a YAML where you specify which library should be installed and which language you want to write. So you're not stick to Python. You can do different languages also in one environment, and then you prepare code, you can upload Python or whatever, and then you have to run it once, and then you can make a revision. And afterwards, get this DOI and can share it, and everyone can work on this version. If you change something, you have a new version for your own, but everything is kind of persistent, so people can really redo what you did. So therefore, I'm wondering what's the difference.
Yeah, so what you're describing, we are in a similar domain to that, right? We are trying to make replicable code artifacts that can reproduce, X years from now for researchers. Some things that distinguish us from other things on the market is one, we are really hitching our wagon to Globus Compute /Parcel. Other places are not optimizing for getting your thing running on HPC nodes, right? That's a big thing. It's you're a scientist, you can bring your own allocation to Garden. Second, we are trying to be really laser focused on this scientific ML set of use cases. So it is really, really, really trying to solve from the perspective of the scientist publishing, what metadata do they want? How am I really visibly linking my papers? my training data sets, my models. So it's like, yes, there's similarities there. We are hoping to be like really, really serving this niche super, super well. That's kind of my quick answer.
Thank you.
Yeah.
I also think CodeOcean, I don't believe gives you a DOI. I don't think a CodeOcean activity is searchable through metadata, but I could be wrong about that.
DOI, it's something, each version gets a DOI you can read. So I used it in my research before I know it, and was just wondering how it's better. But I mean, you gave me a main clue that you really look in performance, that CodeOcean doesn't. So this is a distinguished feature, I think.
Cool. Thank you.
We also have a question from Alex, which is, do you see a nice way to integrate garden models into Colmena style workflows?
Yeah, I mean, like, I haven't like looked deeply into it, but like I'm in a lot of calls with Logan. And yes, we definitely want to do that once we have like the core nucleus of this working really well. Yeah.
Yeah, I like the question, Alex. That's a great, that's a good thing to chew on. Thanks.
Great, thank you.
Thank you.